we are going to be working on a review for your second quiz. You will need to take out a separate sheet of paper because this was going to be an in-class review that we worked on. So if you don't have a piece of paper out, go ahead and take it out. One of the hardest parts and the most important part about this upcoming quiz is that we're going to have triangles or circles that are going to look very similar to each other. And what's going to determine what we do is whether we have angles or side lengths, because we'll have a picture that looks exactly the same, but we're going to treat it completely different whether it's an angle or a side. So that's going to be your main focus of this review today. So when we look at number 1, we see that we have a circle. And again, if I go too fast, just go ahead and pause so that you can get your picture drawn. So when I look at number 1, we have our circle. And with the circle, I see that I have angle measures and arc measures. So when it comes to angles, the key to focus on is where is that vertex located? And when I look at this one, I see that my vertex is on the circle. When the vertex is on the circle, the angle is half of the arc. So because I am giving you the angle measure, you're going to double that. The angle will always be smaller than that arc. So this arc is going to be 96 degrees. But that's not what we were solving for. We were looking for the measure of this arc over here. So we have to utilize the fact that the whole circle is 360 degrees. So we do 360 minus the 110 we have here, minus the 96 that we found, and that's going to leave us with the remainder of the circle, which is what we were looking for, which is 154 degrees. Now moving on to number 2. When I look at number 2, here I see that I have segment lengths, not angle measures. If this was angle measures, my vertex would be inside the circle and I'd be adding the arcs and dividing by 2. But I don't have angle measures, I have arcs. Or I have segment lengths. So when I look at this, I see that this is going to be a chord relationship. And when you have your chord relationship, it's piece 1 times piece 2 equals piece 1 times piece 2. So if I'm looking along this segment, I multiply the 2 pieces of those segments together. So this becomes 5 times 8 is equal to, now my other chord, x times 4. So that's going to give us 40 is equal to 4x. We divide by 4, and we find that x is going to be equal to 10. Again, because I have segments, this is a chord relationship. Number 3, notice how the picture to number 3 looks very similar to number 2. But in number 2, I have segments, and number 3, I have angles and arcs. What's important here is that when I look at the pieces that I'm given, 41 is this arc, 75 is this arc, and those arcs are connected to those angles. So when I look at the fact that my vertex is inside of my circle, this is arc 1 plus arc 2 divided by 2 gives me my angle. So that's going to give me 116 divided by 2, which is going to make it 58. But we have to be careful because 58 isn't the angle that we were looking for. 58 are these angles right here because the arcs are connected to those angles. I'm looking at the angle next to it, and those are forming a straight line, so we have a linear pair. A straight line is 180 degrees, so I do 180 minus 58 to find that the angle I was really looking for was 122 degrees. Number 4, when we look at number 4, an important thing to note here is that this is the center of my circle, and this is a diameter. That's cutting my circle in half. And so since this is 180, this is going to be a right angle. So here we have 6x plus 15 is equal to 90. We move that 15 over. 6x is equal to 75. We divide by 6, and we get 12.5. Again, decimals are always going to be okay. Or number 5. Okay, so looking here, we have our angle coming from the center of your circle. And when it comes from the center, that means that this angle is the same measure as this arc. We currently don't have that arc, but I do have that everything else is 234. The whole circle is 360, so we do 360 minus 234, leaving you with 126. So if the arc is 126, then the angle is 126. Number 6, again, we look, do we have angles or do we have segments? In this case, we have segments. So yes, we would like, oh, the vertex is outside the circle, big arc minus small arc. That would be true if we were dealing with angle measures. But here, my line cutting through is a secant because it touches in 1, 2 spots, 1, 2 spots. So this is going to be our secant relationship. And for secant, this is outside times the whole is equal to the outside times the whole. So here the outside piece is x. The whole piece, you are putting those together. Remember, you are adding. It's segment addition. X plus 8. And then on the bottom, again, it's outside times the whole, which is 16. We distribute. X squared plus 8x is equal to 48. We move that over. We factor. Don't forget, when we factor, we're multiplying to the outside, adding to the middle. So that gives us x plus 12, x minus 4. And that means x is a negative 12, x is equal to a positive 4. X, though, is a segment length, which means it can't be negative. So we have one solution when x is equal to 4. Number 7, when we look at number 7, we have segments again, not angles. So I see here the first segment on top is touching in 1, 2 spots. So that's going to be a secant. On the bottom, my segment is touching in only 1, which makes it a tangent. For this secant, like we just talked about, it is the outside times the whole. For a tangent, it's the outside squared. So this becomes 2 times 18 is equal to x squared. 2 times 18 is 36. We square root, and we find that x is going to be equal to 6. Now x is, remember, technically plus or minus 6, but because x is a segment length, it can't be negative, so it's just a positive 6. When we look at number 8, number 7, number 8, the pictures are the exact same, but in number 7 I have segments, and number 8 I have angle measures. So with angles, it all depends on where is your vertex. Since our vertex is outside, we have big arc minus small arc divided by 2 is the angle measure. So in this case, we have 202. As we draw that angle, we have these intercepted arcs. So it's the big one minus the small one cut in half. 128 cut in half. Our missing angle is 64 degrees. Number 9 is one that throws us off all the time, so make sure that getting ready for your quiz, when you see an inscribed quadrilateral, Our instinct is to take these two angles and set them equal to each other. That is not true. The opposite angles are supplementary. So we take 5x plus 6 plus 128, and we set that equal to 180. Those are on the same side, so we combine like terms. We move the 134 over. 5x is equal to 46, divide by 5, and we get 9.2. So remember, for inscribed quadrilaterals, they are supplementary, not congruent. All right, for our last problem, this one's really crazy. We have a whole lot going on. Where we want to start is not even looking at what we need to solve for. We're going to look at these angles and their vertex. We see that these are going to be on the circle. So when I copy these up, the angle is half of the arc. So if this is 32, this is 32 times 2, making this arc 64 degrees. If I look over here, this one's 49. Again, that's on the circle from that same vertex. So I have my intercepted arc. If this is 49, this is 2 times 49, making this arc measure 98. I keep on following that around. So again, that 27 is on the circle. Inscribed angles are half of the arc measure. So since I have the angle, I'm going to double that to make this 54 degrees. And once you have all of those, the only thing remaining is that, but we know that the whole circle is 360, so we do 360 minus 144, minus 98, minus 64, minus 54, all of those ones that we just found, and that leaves us with 144. So that gives us all of our arc measures. Now we have a bunch of angles left to find. So one way to do that is if I'm looking at this arc right here, notice how it's coming from on the circle again. Well, that's intercepting the same arc that we had over here. So if this is 54, I take half of 54, and we see that's going to be 27. So we see that this angle is the same as that angle. If I look at this one right here, this is again on the circle, so I take half of 144 to find that this is going to be 72. And I can follow that all the way around the circle. If I look over here, this angle again is on the circle, covering that same 144. So this is half of 144, which is 172. And we could just continue that all the way around. If I'm looking at this angle, it's on the circle that's intercepting that 98. I cut 98 in half to get 49. If I'm looking down here at the bottom, this angle is connected to this arc. So we take half of 64 and we find that this is 32. So far, everything that we've looked at has been inscribed angles, vertexes on the circle. But if I'm looking for, let's say this angle right here in the middle, these are vertical angles. They are connected to this arc and this arc. And when it comes from inside the circle, remember you add the arcs together. So I add 98 plus 54, and I cut that in half. So that's going to give me 152. Cut that in half, and that gives me 76. So this angle is 76, and this angle is 76. If I want to find the angle next to it, we do our linear pair, subtract from 180 to find that 104. So now that we filled out all of that, you can look at all those angles and fill in the missing arcs and the missing angles. So just pay attention to the difference between the arc symbol and the angle symbol. So that kind of summarized and went over a bunch of the angle relationships. Just remember for your quiz, is it an angle or is it a side length? Those two things have two different approaches. All right, we are all done.